Okay, welcome to the Practical Physics walkthrough. If you're watching this, you are probably a member of Godalming College Physics Department, and you have got young slits with a laser experiment this week. And the idea is that I'm going to walk you through how to do this experiment fairly quickly so you know what you're doing. Okay, so really hope that you have already had a look at the lab script. It's available on Godalming Online, and that you have looked to see what equipment you're going to need, a little bit of theory. Of course, you probably want to have looked at the textbook if you haven't already done this in class. And in fact, even if you have, you probably want to remind yourself of it. The really big thing about this experiment is that we are using a class 2 laser. If you do actually force yourself to stare at it, it will cause your eye permanent damage. However, the energy is being diffused through a double slit, and as a class 2, it's designed that you will have your blink reflex and therefore no permanent damage will occur. But the safest thing is do not look into the laser beam. If we do catch you trying to shine this laser at somebody else, you should expect to be seeing the assistant principal the same day. That's how serious this is. So, I'm going to let you read this, but the basic gist is we're going to shine the laser onto some graph paper, we're going to look at the pattern, we're going to mark the pattern, then we're going to measure the pattern. So let's quickly show you one little bit of that now. Okay, so I've got the setup here. We've got the laser box, we've got a lab jack. You'll find all this stuff, by the way, at the back of the lab, just either in the cupboards or on the shelves. We've got some meter rules. We've got a board which is in the box with this, and we've got a board clamp which is down there. It says board clamps, and we've kind of set it all up. Everything's been blue tacked in place apart from the board. And you might already see, because I've got the laser on, in fact, always turn the laser on straight away. You might already see, just very faintly, just there is a little faint red pattern. I'm going to kill the lights so that we can see that pattern a bit more clearly, and I'll show you how to mark it. To start with, I've been careful to make sure that my lab jack is set up at the 0 and that my front of this housing is also set here. That's actually a bit naughty because the slit, oh, I can't see it. The slit is actually set back a little bit, but we're just going to have to cope with that systematic error. This isn't marked, so we're not going to start prodding around in there. In fact, I don't want you touching inside there because if you smudge it, it's a right pain. So we're just going to live with the fact there's a little going to be, 1 or 2 mil systematic error there. I'm also being careful to make sure that I've aligned this so that the front of the... Oh, my camera's got stuck. Front of this board is exactly at the right distance. So I've rather annoyingly got this set up to be on that scale, which is fine. So in fact, if I want my initial one to be 40, I need to bring it forwards to that point there. Okay, so I'm actually assuming the board is vertical. I could use a set square one to ensure that. So at this stage, I want to just simply mark these. I've got a nice sharp pencil, being careful not to look into that laser, and I actually prefer to mark the left-hand edge, but you can mark the centres. Basically, from experience, we know that if we try and do all of these, we get really poor results. So we're just going to measure the middle 8. It doesn't matter what order you do them in. I'm actually going to go for the centres this time because I think I can see those more clearly. So marking 1, 2, 3, 4, 5, 6, 7. I'm going to put my hand over this just to make it darker so I can see. So just put my hand there so I can see 8 there. And now when we turn the lights back on, you can see the pencil markings clearly. That was at 40, so I'm just going to make a little note so that was at 40 there. I'm just going to double check I did do 8 gaps. 1, 2, 3, 4, 5, 6. Oh, that's annoying, isn't it? I've done 7 gaps. If I'm honest, I did that deliberately because this is a really common mistake. What I've done is I've marked 8 fringes rather than 8 gaps. So make sure this is nicely shadowed so I can see, and I can see an 8th fringe there. So 9th fringe. So I've now got 9 fringes marked, which is 8 fringe widths, 8 separations between the fringes. So what do I do next? Well, all I have to do is put your lights back on, move this to 20 centimeters further away to 60. Well, that's bang on 60. Now I don't want to have this overlaid, so all I'm going to do is, whoops, all I'm going to do is adjust this clamp stand, what am I talking about? This lab jack, so it's a little bit lower. I'm just going to move it down a couple of centimeters, so now you can see that the pattern is like 1 centimeter below. Does it have to be exactly 1 centimeter below? No, but that's so neat, isn't it? So I could now mark on here that that is 60 centimeters. I probably ought to put the fact that that's in centimeters just so I don't forget. And I can go through the same process again. I can mark 1, 2, 3, it's a bit off. Just shadow it so I can see what's going on. 4, 5. Really weirdly, what you're seeing on the camera in terms of the laser light is clearer than what I can see physically in the lab. 5, 6. If you need to make this darker, and I suspect you will, there's nothing wrong with just grabbing a piece of paper or a piece of cardboard or something like that and just trying to block out a little bit more light so you can see what's going on. What you need to be careful of is that you don't move this board. That'd be a nightmare. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's my next one's marked. So I now move the lab jack down another centimetre. I move the board back another 20. Make sure it's all nicely aligned. And you can see the pattern's getting wider. Mark those, move it down another centimetre, move it back another 20, and repeat. And you're going to do that all the way from 40 centimetres all the way through to 2 metres, and just so you can get a feel for what the 2 metre pattern will look like, you can see it all the way over here. And you have got to be prepared to get this dark if you have to. Okay, so whatever it takes just to get that nice and dark so you can see that pattern really clearly to mark it off. As it happens, you'll be working in a darkened lab. I've not made it particularly dark today, so we can see what we're doing. What you're going to end up with is a set of results that looks a little bit like this. So a little bit like this example I've given you on the sheet. And all you're going to do is use a ruler just to measure across those 8 fringes, also say 9 marks, which is 8 fringes, and I've tried to make that clear here as well, and tabulate it, and then you can plot a graph. Once you've got the graph, you can work out the gradient, and you can use the fact that we've got this formula and assume that if we're plotting W over D, then the gradient will be lambda over S, where S is the slit separation, and that slit separation we're just going to tell you is 0.1 millimeters. I've given you a very clear view about how I want the uncertainties of this experiment calculated and the percentage difference. Please make sure it's done really clearly, really bold in your lab book. We always want uncertainties done, but for this experiment I want them done very clearly, please. And just as a last little thing, we want you to work out if you feel that the percentage uncertainty, percentage difference makes sense, i.e. is that percentage difference small in your percentage uncertainty, which it should be if the experiment has been carried out correctly. There are a few things, like obviously we haven't bothered with the percentage uncertainty of the slit width, we don't know that, and we also do not know how certain the manufacturers were about that 650 nanometers. So they didn't quote an error on it. If you were to dig around on the web, you would be able to find a spectrum which showed exactly what wavelengths were being transmitted from this laser, but we're not going to get to do that today. Okay, I really hope that that was a useful overview of this experiment, and I hope you enjoy conducting it.